Hi, good morning. Thanks for joining today's live learn session. This is Terrence Young. Today we have two presenters, me and my coworker Alec, and we'll go over an exciting topic about optimizing performance and cost by using Azure Disk Storage. So I'm Terrence Young. I'm based in California, so nice weather today. Alec, you want to introduce yourself?
Yeah. Hey. Yeah. Thanks, Terrence. Yeah, I'm Alec Becker. I'm a product manager with Azure Storage, and yeah, we're like Terrence says, we're here to talk about optimizing performance and cost. But yeah, back to you, Terrence. Let's get into it.
Yeah, thanks, Alec. So let me go to presentation mode here. So it will be a fun topic today. And please feel free to check the link here to access the module. And you can also use a QR code to get access. And this is where the learning material will be. And we will go through the modules. Today, we also have two moderators joining with us, Yuanming and Raman. Please say hi to the moderators in the chat. They will be helping taking the questions in the chat and provide answers. So this will be the module we're going to start today. And we have 3 learning objectives today. Also, please say hi and ask questions in the chat. We will try our best to answer all of them. And hopefully you will get a lot of learnings today from the interactive session today. So we have 3 learning objectives for today's topic. First is the disk types that are available in Azure. We will go through all different types of disks and their performance and what applications are suitable for which disk. And second is how disk performance works. We'll talk about different performance metrics and also features that can help enable those high performance. Third is performance scaling options. So we will go through the presentation and also in a combination with quick demos to show you how to do some stuff on Azure Portal. And at the very end, we will also have a quick quiz to test your knowledge. Okay, let's get started. So imagine a daily scenario. You are an IT professional and you work for a medium-sized financial service company. And one day, your CTO would like to migrate your current on-prem services, including different applications, to the cloud to reduce the number of physical servers that you maintain in your current data center. So as part of the migration strategy, you have to determine the suitable approach for your cloud-based storage infrastructure. You have to pick the right disks for the right application. So after this learning session, you will be able to optimize performance and also cost, and be able to select the right type of disks and capabilities for the cloud migration project. Okay, let's get started about the exciting part about the disk storage options. So we have a wide range of product offerings in Azure Disk Storage, and ranging from low-cost solutions to very high-end performance solutions. And the color coding also shows what the new products we launched around end of last year. We have Premium SSD v2, general availability last year, and Cloud SAN is currently in preview and targeting to be GA this year. So let's start from the low-cost storage solutions. So standard HDD is a low-cost storage. Those are hard drive disks, magnetic disks that have moving spindles. And those disks are slower, and also the variation in speed is higher than the other SSD solutions. So you can use standard HDDs disks for any type of VM. And if you want to minimize your cost for less critical workloads and also development or testing environments, you can use standard HDD. You can also use it for backup, low-end file servers, etc. So it has, so bottom of the chart shows you about the single disk maximum value. So it can, single disk maximum size can be 32 terabytes with a maximum IOPS of 2000, maximum throughput of 500 megabytes per second. And the provisioning model is a performance scale with capacity. We will show you a few examples later in the live demo session. And next level of this is a standard SSD disk. It performs more consistent and compared to the standard HDDs. There are cost-effective storage options for VMs that need a consistent performance and at a lower speed. Standard SSD disks are not as fast as the other premium SSD or Ultra disks, but they do still provide a single-digit millisecond latencies, and they can provide up to 6,000 IOPS and 750 megabyte per second throughput. So you can attach standard SSD disks to any type of VM, regardless of the size, and use standard SSDs when you have budgetary constraints and also a workload that isn't performance intensive. For example, you can use it for web servers, you can use it for big data, entry-level applications, and small databases. And also some test servers can also run on standard SSDs. So we also offer disk bursting features for standard SSD. So for those performance features, my colleague Alec will also show you more details in the future, in the coming slides. So after standard SSD, the next on the menu is our higher performance premium SSD disks. So when you want the better performance on the IOPS and throughput, you go to the premium SSDs for IO-intensive data production workloads and also container volume. So it has a big jump on the maximum IOPS you can get from premium SSD compared to standard SSD. And with bursting feature, you can go even higher to 30K IOPS. And also it has improvements on the throughput, and its provision model is same across standard SSD and HDD disks. So next level is our premium SSD V2. So it is a new product we launched end of last year, and this is giving even better performance on the latency. It can provide sub-millisecond latency for even higher performance requirement applications like SAP HANA, SAN, and Tier 1 workloads. It also has a much improved IOPS you can choose. It goes to 80K and 1,200 megabyte per second throughput. Another important thing to mention, the feature is called flexible scaling at 1 gigabyte granularity. This means that customers or users can provision the size of the disk and also IOPS and throughput independently, instead of picking a disk tier that was preset for standard SSD premium SSDs. We'll talk more later in the next slides. And the best performance disks in our Azure Disk portfolio is the Ultra disks. So it provides even lower latency compared to premium SSD V2 with low sub-millisecond latency, and for SAP HANA, SAN, and Tier 1 workloads. So the big difference is also the jump on the IOPS maximum it can achieve compared to premium SSD V2 and higher throughput. So we also have a new product that is currently in preview is Azure Elastic SAN, and it's cost efficient at scale, and its targeted workload is for Tier 1, Tier 2 workloads, database, VDI hosted on any compute options. So on the whole SAN level, it can achieve a total IOPS of 2 million and with a throughput of 32,000 megabytes per second. And on individual volume level, it can achieve 64,000 IOPS and 1,000 MB per second. So this is a kind of landscape of current products we have, and how to choose the right solution for the applications. We will also help you to go through a kind of a decision tree to help the users to pick the right solution for the right application, and also in the meantime have the right cost. So first, before you pick a disk, first you have to understand your application's current performance requirements, including latency requirements, IOPS requirements, and throughput requirements. Especially for IOPS and latency, it can vary a lot. It depends on the application and you are hosting or going to host on cloud. So we can go through this decision tree, for example. First, as you have the IOPS requirements, you can first decide if it is I/O in throughput intensive. And you can have the number of peak IOPS throughput per terabyte and check about the average IOPS Mbps per terabyte. So if your IOPS and the throughput requirement is not that intensive, you can check, we can go with solutions like standard HDD or standard SSD. And at this point, you have to check about if you require consistent performance. Standard SSD offers you more consistent performances and better latency. So if you have a relatively better latency performance, you go with the standard SSD. And for best cost efficient solutions, you go with a standard HDD. So in another scenario, if your application is throughput performance intensive, then you have to go the other way and check if it requires a millisecond latency. So latency is also a critical part separating the differences between premium SSD and other disks. So if it doesn't require a sub-millisecond latency, and also double check if it requires a high IOPS and Mbps. If this does not, then you can use premium SSD. If it requires high IOPS and Mbps with also a sub-milli latency, you have to check if you need the extreme performance for your application or not. Then you can decide whether Ultra Disk fits for you as a fastest disk, or if you choose Premium SSD v2 as the best price performance on Azure. So when you have to decide the IOPS and Mbps, you can refer to the previous slide about the maximum you can achieve here, and also compare that with your requirements and need for the application. Okay, let's switch gear a little bit. We'll come to a quick demo about how to pick the right disks and also how to flexibly configure your Premium SSD v2 and Ultra SSD disk as example. So we have two types of disk configurations. One is fixed disk tier configuration. So for standard HDD, standard SSD, and Premium SSD disks, we have disk tiers with preset size of disk, IOPS, and throughput. So user has to pick the disk size. And for Premium SSD v2 and Ultra disks, these two types of disk, user has the flexibility to configure the performance individually, which means they don't have to stick with one size at fixed IOPS and throughput. User can pick them separately. Here, the chart only shows about the maximum a user can configure within a certain amount of capacity. So let's quickly go to a demo. I will show you better how to understand the scenarios here. So we are at Azure portal, and we can go to create a resource and select manage disks. Okay, let's create some disks. So you have your own subscription. So currently we are just using a testing subscription for the live learn. And we give a name as live learn, and we pick a region. And we have the option to choose either which zone to use. And here, when you are trying to select the right disk type, you can select change size to view all the available disk sizes in that region or in that zone. So here, this zone has supportability for different types of disk. You have a standard HDD, and you can see it is by disk tiers. You can pick the right tier for your right application requirement, and you can also customize. and then you can click OK to select the right tier. So for standard HDD is same as standard SSD. You have different tiers and also premium SSD. You'll also be able to find out what are the maximum burst IOPS and the burst throughput if you enable the bursting feature. And different than the fixed tiers, performance tiers. If we go to premium SSD V2, there's no tier selection. Instead, you have 3 input boxes for you to configure the capacity, IOPS, and throughput separately. So here you can input the capacity you need. For example, I need 1 terabyte of storage. So for premium SSD V2, it comes with 3,000 IOPS for free, and you can choose any IOPS you want in this range, limited here. So for example, I want 10K IOPS, and I want to set throughput of maybe 200, for example. Then you can create your premium SSD V2 disks. So it's the same for Ultra disks. You can also configure them separately. Yeah, that's just the big one example. Okay, let's just create one disk. So one good thing about premium SSD V2 flexible configuration is you no longer need to over-provision on a very big capacity to get the IOPS and throughput performance you need. For example, if you need 20K IOPS, for premium SSD, you have to provision a P80 disk with 32 terabyte size of disk. But in real case, maybe you don't need that big size of disk. However, in premium SSD V2, you can get 20K IOPS with much smaller size of disk. You can provision the size you need, and in this kind of situation, you may be actually saving cost compared to provision a very large premium SSD disk. So that's a cost saving part for premium SSD V2. Let's see if we have the disk. Okay, deployment is ready. We can go to the disk. So this is a premium SSD V2 disk we just created with 1 terabyte size. And you can also change the size when the disk is actually in use. And you can change the size to bigger numbers, and also you can vary. You can also change the IOPS corresponding IOPS and to any numbers within the limit. Yep, so it's updated. Okay. So this quick demo shows you how to configure a disk, pick the right disk size. And let's go to the next topic. Let me quickly check on the chat. Okay, so let's go to the next part. Understand the disk performance and characteristics. So we have to go back to the basics a little bit to understand the application requirements and the performance matrix. So we have to choose the right size of disk types. It's very important to understand the performance indicators and your application requirements. So the top 3, the most important ones here are IOPS, throughput, and also latency. So IOPS is a number of requests that your application sends to the disk in 1 second. So it directly affects your application's performance. And some applications like websites, retail websites, need very high IOPS because it needs to handle a very high amount of transactions and clicks like every second. So it requires high IOPS. And throughput is amount of data that your application sends to the disk in a specified time interval. So it's also called data transfer rate, and it's measured in megabyte per second. We also have an equation actually to estimate the limit of throughput, because if you have an average input-output size and times the number of input-output per second, then you actually get the per second throughput data transfer through over 1 second. The last part is the latency. It expresses the time it takes your app to send a request to the disk and also receive a response. The latency also put a limit on the actual effective IOPS. So if your latency is 10 millisecond process, your application will be kept at 100 operations per second because of the processing time if your disk can only handle like 5,000 IOPS. So it is significantly improved if you have enabled read-only host caching. So we also talk a little about the caching in the later parts. Got it. So I saw a question from the chat. Is it possible to lower the size also? So I assume it is about the picking the disk size. So currently we do not support lowering the size of the disks. We only supporting increasing the size of the disks, because lowering the size will have high risks of accidentally removing the data already there. So it's very tricky to reduce the size of the disks. So currently, officially, we only support increasing the size of the disks. Okay, so let's talk about one scenario here. So you have to pick the right combination for the virtual machines together with the disks. So in some situations, if there might be a virtual machine or disk I/O capping that limits the performance for the application. So if you don't have the right size of the VM, or if you don't have the right size of disk, either of them can be the bottleneck to limiting the performance of your application. So in this scenario, you have an application, and the requirement for the application is 15,000 IOPS requests. The VM, it actually supports only 12,800 IOPS. This is the standard V8S v3 VM. Although the disks attached to it, we have one OS disk, two data disks. Each data disk is capable of handling 7,500 IOPS requests and can respond also with the same IOPS. It's a premium SSD disk P40. But the VM itself is capped because the VM has a maximum IOPS of 12,800. So it can only respond to the application with 12,800 IOPS. So in this scenario, the disk is not the bottleneck, but the VM is the bottleneck. So this is the VM IO capped. So we also share a few other examples. I think, Alec, you would like to share some more examples about deeper dive on this topic?
Yeah, thanks, Terrence. So yeah, Kimberly, if you could switch over. Yeah, perfect. So yeah, like Terrence just went over, there's possible combinations where your disks are performing higher than your VM, or your VM is performing higher than your disk, that could be limiting your overall application performance. And so on the previous one, I think Terrence went over a VM capping situation. I've got another example right here just to quickly solidify it. Say you have an application that gives you a request for around 1,800 megabytes per second of throughput, which is like the equivalent of what these disks can actually do right here. However, the VM itself can only do about 1,200 megabytes per second of throughput. So from there, actually, the VM actually limits the performance and reloads those requests off to the disk. The disks see that, and they can respond back with all that performance. However, the application does see limited, not the performance it requested, but the performance that the VM could actually provide. So yeah, in this situation, we call this VM bandwidth capped. But on the flip side, what if your disks are not able to give the performance that your VM needs? In these exact same scenario where an application gives a request for about 1,200 megabytes per second, we see the VM sees this, and the VM says, hey, I can do this request. It's able to relay those requests off effectively to the disk. However, the disk can only do 200 megabytes per second of throughput, and they respond with that 200 megabytes per throughput, surfacing up 600 megabytes per throughput to the application. So this is no good. Like, we want our VMs and our disks to be matched effectively so they can serve your storage properly. So to help with manage finding bottlenecks in your storage system on your VMs and your disks, we put out these IO utilization metrics. So these metrics are pretty cool. Basically, what they tell you is from 0 to 100%, how much your IOPS or bandwidth you're using for your data disk or your OS disk. And then on your VM side, it also gives you a number from 0 to 100% of how much cached IOPS you're using, cache bandwidth, or the uncached IOPS and bandwidth. So for example, say if I had a particular disk that could do 1,000 IOPS and it is running at about 800 IOPS. What this metric would tell you, if you look at the data disk IOPS consumed, is that 800 over 1,000, which would be about 80%. So the key thing with like these is like it really helps you find where your storage could be limited. So yeah, so if you ever see one of these metrics running at 100%, that's where you know your storage system could use a bump in performance, and we'll get to how you can bump those performances up with our various offerings. But you could also do it by switching your disk queue. So yeah, let's get into, I've got a demo for this, not that one quite yet, to show you these metrics in action. So I've got a setup in the portal for an with an E16 v5. And as you can see, it can do about 2,500 IOPS. Attached to it, I've got, what is it? 1, 2, 3, and I believe these are P40 disks, and they can do about 7,500 each. So roughly about, what is that? Roughly around 2,200 IOPS. So 2,500 IOPS, 2,200 IOPS by the disks. They're roughly the same. And so I've got an application actually running inside here. And forgive me, I know it's a little small. And I can't figure out how to zoom in on this one. But if you look at the very bottom, this application running is only consuming about 15,000 IOPS, when the whole system should be doing around 25,000 IOPS. So what we can do to figure out exactly, hey, what's going wrong, we can go ahead and take a look at our metrics. So I've built a little dashboard here, and I'll run through them one by one. So at the VM level, I've got the VM uncached IOPS consumed metrics. And so these are telling me from 0 to 100% how much of the uncached IOPS I am actually using. And we see that coming at about 60%. So the bottleneck clearly isn't there. So let's go up. With consumed percentages for the VM as well, we see it at about 10%. Again, the bottleneck is not there. So let's go ahead and double click down on the disks. So, okay, here, the data disk IOPS consumed percentages. So yeah, I've got 3 disks attached, one at LUN 0, 1, and 2. And LUN 0 and 1 are running at 100%, and 2 is not. It's running at 0%. So what this is telling me is that disk at LUN 0 and 1 are being utilized, but disk 2 is not at all. So this means I probably need to go reconfigure how I'm striping these disks, or my application to actually use disk 2, the disk at LUN 2. But yeah, so that's how you can use these metrics to kind of help pinpoint, hey, and troubleshoot, hey, where am I going wrong with my storage performance? Where is my application actually using the disks that are attached? Cool. But yeah, so let's get into another topic about performance. And this is called host caching or disk caching. And what this is it's low latency and high performance IO. And we were able to achieve that by bringing storage closer to your virtual machines and using it as a cache. The host cache is a combination of caching and local SSDs to the hardware that the VM lands on. So we can configure host caching to the workload's IO pattern. So like we have a read-only option and we have a read-write option. So if you know that your IO pattern is very read-heavy, you're going to want to utilize the read-only option. If you have some reads and you have a combination of writes, you might want to consider the read-write option. And I'll get into the pros and cons of these things as well. But one thing to note about the host cache, it has independent performance limits of the non-host caching VM performance. And it enables you to get high performance that can exceed the storage limit, the performance limits of your Azure disks. And so if you take a look at the diagram, this is kind of how host caching can work. So you can see the application can make a request to the VM can make a request to the host cache, and the host cache, if the data is available there, will actually surface it back up to the VM and back to the application. If if the data is not in the host cache, it will then reach out to the disk. The disk will respond and bring that back to the host cache, and then surface that back through the VM into the application. So yeah, on our VMs, particularly like the V3 and younger, actually, we do have separate limits for our host caching. So you can see like, hey, there's actually a particular IOPS and throughput that can be served off the host cache, and then there's also separate limits for it actually reaching out to the disks. Cool. Let me give you an example of how a read-only cache hit would actually work. So we recommend this for data disks with heavy read IO patterns. And when the IO is actually served off the host cache, it is the disk's performance is not affected whatsoever, and it's just served up from the cache. You can your application can actually achieve higher throughput than the underlying remote disk because of this. So I'll run through an example of what a cache hit would look like. So your application would reach out to your VM. Your VM would take a look at the host cache to see if the data that it's requesting actually lives there. And if it is there, we'll serve it straight up from the host cache back to the application. Now let's talk about a cache miss. So in this example, the application reaches out to the VM. The VM looks at the host cache. The cache does not contain the data. So then it'll reach out to the disk. The disk serves up the data back to the host cache to reside in the host cache if it needs to be served up again, and then through the VM and to the application. So if you're getting if you're able to read, if you're reading constantly in like a similar location where your data resides, host cache will just short circuit that and just serve it up from the host cache. So yeah, host cache, because the data is closer to the VM, it'll reduce the latency and it will not dip into the performance limits that resides on the disk. All right. All right, so now let's give an example of what happens when a write is happening. So for a write on read-only caching, in this case, the application would say, hey, I want to write to a particular place in our disk. The VM will say, okay, let me reach out to the host cache and write there first in case that data needs to be served up again. And then that data then gets propagated to the disk, where we finally give an ACK and the write operation is completed. Next, we'll go over, so that was read-only caching. Now I'm going to go over what read-write caching performance looks like. So reading on a read-write caching setting is just like a read caching. If customers want to use read-write caching, their application must have a proper way to write the data from the cache to the persistent disk. So like SQL Server has a setting to do this where writing cache data to the persistent storage is already done on its own. Writing on a read-write cache has a lazy write back to remote storage. So let me demonstrate this with our diagram. First, the application is going to give the write request to the VM. The VM will then write it to the host cache, and from the host cache, we'll actually give an ACK then saying, "Hey, the write is complete," and then there we go, and then it'll lazily write it to the disk. So the pros of this read-write caching is that you get your writes completed much faster. However, the cons of this is if since it's a lazy write to the persistent disk in the background, if there's any interruption between the host cache writing to the disk, that data could be in the VM reboots, or there's an application crash, or something bad happens. That data doesn't exactly get persisted to the disk. So it's best used for kind of like temporary data, or if data that you're kind of willing to lose, which I wouldn't recommend. But yeah, it's good for like OS disk where it's like temporary files and whatnot. Cool. All right.
Hi, Alex.
Yep.
Just adding on to Alex's comments, I think for the host caching, it's supported for, I think, SSD disks, but I think it's not across all disk types, right, Alex?
Correct. Yeah. Oh, thanks, Terrence. Yeah. Just a clarification on, the host caching. It is available on our premium SSD, but it is not available today on our premium V2 and our Ultra disks. Thanks, Terrence.
Yeah.
So yeah, let's get into our next section about optimizing performance and cost and our different performance scaling options. First performance product that I'd like to talk to you guys about is our performance tiers. Our performance tiers are available on our premium SSD disks. And what they allow you to do is scale up and down your performance without changing the disk size. This is great for like planned scale up and scale down events. So say you have like a batch job at night or a batch job over the weekend, you can then scale up during those times. And then when you're running at a lower level at a different baseline time, you can then lower it down. And this is great because for whatever performance tier that you are actively using, you get charged for. So you can scale up for the performance when you need it and get charged at that higher rate. But then when you scale back down to the lower performance tier, you get charged for that lower rate. Oops. So yeah, let me go through an example of our performance tiers. I've got a demo for you guys. Here are the commands I'll be using in Azure CLI. But yeah, let's get into the demo.
Hi, Alec. Just a quick reminder. Yeah, the settings.
Yeah, let me turn this into light mode. I apologize.
You can go to the on the left-hand side, appearance. Yeah.
There we go.
Great.
Sorry, you guys have been coding too long. I like dark mode now. Sorry.
I also like dark mode.
Yeah. Doesn't make good for presentations. Oops. Shoot. So let's get into this performance tier demo. Okay. Yeah. Too zoomed in. There we go. Okay. So, I've got a VM running. I forget exactly what size. What do I have? An E2BSV5. And this can burst up to like 10,000 IOPS. And I think it could do somewhere around 5,000 IOPS regularly. Attached to it, I've got some disks that are, this one right here is the one I'll be changing the performance tier for. It currently can do 5,000 IOPS. It's a P30, I believe. And so let's go into our VM and kind of show you what's going on. I've got an application running on it right now, and I'm just targeting that P30 disk that can do 5,000 IOPS right now. So what I'll go ahead and do is change the performance tier using the commands we had up in the presentation. So let me go ahead and do that. So first thing you need to do, enter your, there we go. So first thing I'm doing is putting in my subscription ID. Next thing I'm doing is putting the resource group name in for where this disk resides. Then I'm putting a variable in for our disk name. Let me expand this. It looks a lot better. And then I'm going to set the performance tier. So previously it was a P30 disk that can only do 5,000 IOPS. Now we're going to change it to a P40, which can do 7,500 IOPS. So I'm going to go ahead and run some AZ command line command to set the subscription for my subscription ID. Next. Oh my goodness. Sorry about that, guys. Next, I'm going to go ahead and actually update the performance tier using all those variables that I've defined above with the disk name, resource group, and the performance tier that I'd like to see it changed to. And so if we give this a couple seconds, it will go ahead and update the performance tier to a P40. And it'll give us that bump of IOPS from 5,000 to 7,500.
Yeah, while waiting, maybe I can also ask a quick question. So
Sure.
for upgrading the performance tiers, can you schedule like upgrade it like at a certain time? For example, if I know during some certain days I need to upgrade it, and after a few days I need to downgrade it.
Yeah, yeah. On our platform, we do give you the ability. We have open APIs, and we also have Azure functions where you can program that up. As far as like a platform scheduler, no, we do not currently have that feature. But I mean, we give you all the open APIs and functionality to go ahead and build that.
Sounds good.
Yeah, thanks, Terrence. It's taking this one so long. Huh. Let's give it a moment. Sorry, I guess I didn't. My sacrifice this morning wasn't enough to the demo gods for this to go well.
Maybe we can check back later and see next on the slides.
Sure. Yeah, that sounds good. We'll come check back on that in a couple minutes to see how that's doing. But yeah, we'll continue on. Thanks. So the next performance feature I'd like to talk to you guys about is our credit-based bursting. So we have credit-based bursting, which allows you to get high short-term performance and get the short burst of performance that you need when you need it. So this is great because it allows you to get cost savings. You can provision your VM and your disks for its baseline performance instead of its like peak performance. As long as the peaks are within like the actual burst limits. This bursting is available on both our VMs and our disks. With VMs, we have VMs that allow you to get eight times the amount of IOPS that it normally does. And with our disks, we have boosts that can give you up to 30 times its IOPS and throughput up to 7 times its normal limits. This comes at no additional cost or setup. This is all enabled by default. And we put these products both on our, or we put this feature both on our VM and our disk to work in conjunction with one another. So you want to have like your baseline IOPS and throughput set the same for your VM and your disks. And you want to have your burst performance roughly the same for your disks and VMs. This is currently available on our premium disk size P20 and smaller, and on our standard SSD disk size E30 and smaller. And this gives you, this also comes along with metrics that you can see in the portal that give you insight on how many burst credits you've actually used. So yeah, one thing to note about this credit-based bursting, I don't think I've mentioned yet, is that we give you guys this burst performance for 30 minutes, 30 continuous minutes if you want to use it continuous, or 30 minutes at your discretion for per day. And then it takes a little bit of time. Then after a day, your burst credits recharge and you can burst again. So let's go ahead and take a look, see if that, oh, there we go. All right, it did go through. I don't know why. Oh, there we go. It just took some time to load.
Yep.
Anyways, back to our performance tier demo. So yeah, our performance tier has changed. It went from the 5,000 IOPS here to the 7,500 IOPS. So yeah, so that's how you can change your performance tier on the fly and get the extra boost in performance that your application needs. Now back to the presentation.
Yeah, great demo. I like it.
Thanks, Terrence. Oh, I lost it. 1 second. There we go. Okay. So moving on to our next, continuing on our bursting topic. So for credit-based bursting, we give you all that for free, and it's available on our P20s and smaller. Now for the P30s and larger, which are the disks 513 gigabytes and larger, we have a configuration called on-demand bursting, or a feature called on-demand bursting, where you can get your normal performance of the disk, but if you want to go above those limits, up to 30,000 IOPS and up to 1 gigabyte per second of throughput on a single disk, you can enable this on-demand bursting, and you pay for the additional performance that you use. So with this feature, there is an enablement fee, and then there is cost associated with every IO that you do above your limits. So we think this is a great feature if you're still trying to figure out like what the right size of disks or right size of performance that you need for your applications that you're running on Azure. So I'll go ahead and show you guys how to create an on-demand bursting disk. So with those commands I gave you that we had up on the presentation previously, the first thing you're going to want to do, so this time instead of using Azure CLI, we're going to use Azure PowerShell commandlets. The first thing you're going to want to do is set your, here 1 second. Let me get this so it's not so cluttered. The first thing you're going to want to do is set your subscription name to whatever subscription you're using. This is my test subscription name. This one kind of takes a little while to run. There we go. The next thing you're going to want to do is set a disk configuration. So with the disk configuration, you build a new AZ disk config object within PowerShell. You give it a location, also known as Azure region. And then you set your disk size. So it's I've got a terabyte disk, and so that's a P30. And then you need to set it to premium LRS or ZRS. just because it's only available on our premium disks. And then you're going to want to set bursting enabled feature flag to true. So we'll go ahead and create that config. After the config is created, we're then going to create, we're then going to create the disk itself. So we're going to use the command line new az disk. We're going to give it a resource group name, and then we're going to give it a disk name, even though that disk name is not going to work because it needs a dash. And we're going to give it the disk config object that we created in the previous command. Oh, sorry, I don't have a resource. It should be live learn. Sorry, there we go. Spelled my resource group name wrong. Cool. So looks like the disk was created. Let's go take a look at it. So I named it on-demand disk 1. And let's go take a look for it. So we've got on-demand disk 1. There it is. So we take a look at it. You can actually, in the configuration section of the portal, you can actually enable our on-demand bursting on and off there. But yeah, so it's already enabled here. But if you want to, you can enable it and disable it in the portal as well. Cool. So that's on-demand bursting. Now let's move into Performance Plus. So this is a new feature. We actually just released a month or so ago, or not even that, I think a couple weeks. But yeah, this Performance Plus feature, it basically increases your IOPS and throughput limits and for your disks. And so it's available on standard HDD, SSD, and premium SSD. Sorry, that's a typo right there. It's not necessarily 1 terabyte and larger. It's actually 513 gigabytes and larger. Sorry about that. But yeah, it's our larger size disks on standard HDD, SSD, and premium SSD. This feature is completely free of charge. You're able to get higher limits on your IOPS and throughput. This feature is currently in preview. We're hoping to go GA with this later this year. But yeah, it's a great feature just to get higher performance for your disks. Oh, and one caveat for this, for Performance Plus, before I move on, the Performance Plus can only be enabled during disk creation. And yeah. So here are our new throughput and I/O targets for standard HDD, SSD, and premium SSD. You can see, like with HDD, you get a pretty sizable chunk of improvement of performance, a 12x improvement on IOPS, and up to an 8.3 x performance and throughput. Standard SSD, you get even get similar performance improvements, and with premium SSD, which already comes with high IOPS and throughput, you get about 2 to 3 times performance improvement on IOPS and throughput. Let me see. Okay, and then finally, yeah, let me show you one last demo for Performance Plus. Oops. So for this one, I'm just going to show you how to create a Performance Plus disk. We're going to use the AZ command, the Azure CLI command line. So what I've got here, this is the command to do it. So you're just basically using your AZ disk create command. I'm then giving it a name. I already see an error. So I'm giving it a name of Performance Plus Live Learn 1. And then you need to give it a resource group. I'm using my Alec Disk test resource group. Give the disk size a high size because our this only works for 513 disk size 513 gigabytes and larger. Oh man, I really screwed up this command. Then you're going to want to set your performance plus feature flag to true. Give it a SKU that performance plus applies to. In this case, I'm using premium SSD, so premium locally redundant storage. And then I'm actually, for this one, this is a little hint for you guys. If you're trying to create a performance plus disk, you can actually create it from an existing disk that is already in use, and you can give it a source disk. So this is if we don't allow you to create a performance plus currently with on current existing disks, but a way to get around that is actually to create a new disk with a current disk being its source. And so you give it a source and you give that source the resource ID. And so I give it a resource ID provided, and I give it a location. I'm going to go ahead and create that. And we see the command running, and the disk was created. So if we go take a look at this performance plus one disk in the portal, there the disk is. We can actually see this P40 disk that usually, and it usually can only do about 7,500 IOPS. That performance has now been boosted to 16,000 IOPS, and I think previously it could only do about 250 megabytes per second, and now it can do 600 megabytes per second. So a substantial increase in performance, all for free using this new Performance Plus feature that we have on preview.
Yeah, I like this feature. It's free and it's very helpful.
Yeah, it's like, why not? Why not take that extra free performance? So yeah, I love it too. Yeah, we're just doing our best to give you guys out there the best performance for cheaper costs. Cool. Yeah, so let's talk about costs a little more. So before deciding on which disk suits you the most, you gotta consider how the billing on the disk is done. How much a disk can cost can vary region by region for all disks. The cost also depends on the size of the disk. How much capacity you're going to provision will impact how much the disk will cost. And then also we do have transaction costs associated with certain disks. So for our lower tier disks, the standard HDD and standard SSD, we do charge for transactions, which are loosely the same as IOPS. But for premium SSD, we don't charge for any transactions. But if you do turn that on-demand bursting on, for all those IOs that you do use to burst up, those transactions are billed for. Also, another factor when coming to cost here on Azure and Azure Disk is the redundancy option that you can select. We offer a locally redundant storage where we store 3 copies of your data within the same data center or zone together. Or we do have a zonal redundant storage available on standard SSD and premium SSD, where we actually save copies across zones or data centers. Another type of cost that that can be incurred is that on-demand bursting. We do charge an enablement fee for and that fee is amortized over every hour that on-demand bursting feature is enabled. And then when it comes to actually like provisioning your IOPS and throughput for UltraDisk and premium SSD V2, we charge you how much you actually configure those limits for. So we have a bunch of flexible options about how you get your performance, how you get your data redundancy, and we bill accordingly to that. So I want to now talk about the transaction costs. So standard HDD and standard SSD, we do have transaction costs. associated with the activity that is done against those disks. And recently, about a month and a half ago, we introduced new limits on those the standard SSD build transactions. So what this is like you still get the same great performance that you get with standard SSD, but now we have upper limits on how much we will charge you for our transactions in a given hour. So if you take a look at like in this table, like an E1 disk with locally redundant LRS, we're only like for a given hour, we'll only charge you up to 6,800 transactions. And a transaction, roughly how we bill for it, kind of varies by region, but for every 10,000 transactions that are done against the disk, it's about 0.2 cents. It's pretty dang cheap. So like we're capping it we're placing these caps in place to help lower your cost and help encourage you guys to come use our products. But yeah, this transactions and IOs are loosely the same thing. Transaction is an IO sized about 256 kilobytes and smaller. If an IO that you guys use on your applications is larger than 256 kilobytes, the IO then is kind of like divided by 256, and that number then is the actual like IOs that we actually bill you for. So cool. Let's get into an example of how this compares now for like billing between our standard SSD, who has the billing cap in place, and the standard HDD, which the billing cap is not in place. So in this example, I'm gonna do a comparison between 32 gigabyte disk for the standard SSD, that's an E4, for a standard HDD, that's an S4. And we're gonna kind of assume that they do an activity of 100 IOPS over a given month. So it just averages 100 IOPS over the given month. So without the transaction cap, previously that would be about 360,000 transactions per hour. With our transaction cap, we wouldn't charge you with 360,000 billable transactions. We just cap that at the E4's limit, which is 4,340 or 400. And so that equates in transaction cost about for an entire month of about $6.33. Added on top of that, the capacity cost associated with that is $2.40 because you pay for capacity and then the transactions on top of it. So in total, for running 100 IOPS a month average, a standard SSD will cost you around $8.73. Conversely, with our lower tier product, the standard HDD, if you run that 100 transaction a second workload over the month, that would actually cost you around $14.68. So it's actually in high transaction workloads, it can actually be cheaper to run your workload on standard SSD than standard HDD. Standard SSD also has the benefit of having more consistent and reliable IO, giving a better SLA, and has better features like bursting. So yeah, there are plenty of benefits for coming over from standard HDD to standard SSD. And now we have the benefit of it being capped on how much you can actually be billed for. So finally, I kind of want to just do a review of the different performance options we went over and how you should think about them and when they're best suited for different situations. So I like to think of like, hey, what if I have like unplanned events where like or planned events like a Black Friday, or like an unplanned event where like, hey, there's like a sudden burst of activity. When would I want to use either one of these products? So if you're trying to work around an unplanned activity, we recommend our two different like bursting products, our credit-based bursting or on-demand bursting. If you have more of a planned event for scaling up and scaling down, that's great for performance tiers. And just for scaling up and having that nice, great performance, go ahead and go with our Performance Plus. Next, think of how long you need the higher performance for. So if you need that high performance for short term, again, our bursting products are great for that. So go with credit-based bursting or on-demand bursting. But if you need that more longer term duration, sustained high performance, go ahead and go with tiering up your with performance tiers or increasing that performance with Performance Plus. With these different features, we have different costs associated with each. With credit-based bursting, we give that for free. On-demand bursting, there's an enablement fee, and then there's costs per transaction. For performance tier, it's a fixed cost. You essentially pay for whatever tier your bursting or your tier. You pay for whatever performance tier that you are at. So if you go up a tier, you say you go from P30 to P50, you will pay for that P50 cost. And then when you tier back down to that P30, you'll be then charged for that P30 cost. With Performance Plus, we give you all that performance for free. So yeah, that one's kind of a no-brainer. Go ahead and use that feature. These performance features are all available on different disk queues. For credit-based bursting, we have this available on our premium SSD and standard SSD on sizes less than or equal to 512 gigabytes. For on-demand bursting, it's premium SSDs on sizes bigger than 513 gigabytes, so our larger premium SSDs. Performance tiers are available on all premium SSDs. And then Performance Plus is available on our larger size premium SSD, standard SSD, and standard HDD. Other considerations you want to take a look at for performance and cost is latency. For credit-based bursting on premium SSD, it's low single-digit millisecond latency. For standard SSD, it's a little more higher, like mid, like around 5 to 10 millisecond for latency for standard SSD. For on-demand bursting, again, it's on our premium SSD, so that's low single-digit millisecond. And same with performance tier because it's only on premium SSD. But for performance tier, it just really depends on which product you're using. And then finally, how you enable all these products. Credit-based bursting comes for free and is enabled by default. So there's no work you need to do to get that working. For on-demand bursting, since there is a cost associated with using it, we do require a manual enablement. With performance tier, again, because it changes cost, we require a manual enablement. And for Performance Plus, currently we do require a manual enablement for now. Now I'm going to go ahead and turn it over to Terrence to close us out with the knowledge check.
Yeah, thanks, Alec. It's really insightful presentation, and the live demo is also, I like it a lot.
Yeah, thanks, man.
Yeah, so let's go to the last part, knowledge check. This is a fun quiz, and you can actually access the knowledge check by using the link here, or you can use a QR code. So we have total 3 questions, and I'll give a minute to access this link. So the first question is, an administrator must select the disk type that provides the highest IOPS for a new virtual machine. Which disk type should they use, assuming their region supports all disk types? A, Azure Disk Storage, B, standard HDD, C, premium SSD. Okay, I am seeing the answers coming in, and currently the answers are correct. I will reveal the answer in a minute. Okay, I see most of the audience select the right answer. The correct answer is A, Ultra Disk Storage. There's some people selected the premium SSD. If you can go back to the earlier slides or the training documentation, that the premium SSD actually offers a relatively lower highest IOPS that UltraDisk can offer. So UltraDisk is the top performance storage, disk storage solution. So A is the correct answer. Ready for the next one? Second question. You are running an application that requires 15,000 IOPS on an Azure VM. You are provisioning one VM with a standard D8S v3 tier virtual machine. The virtual machine provides 12,800 IOPS. And we also have a P30 operating system OS disk with 5,000 IOPS and two P30 data disks, each with 5,000 IOPS each. So which following statement is correct? First, you have met the application's demand. The application's demand is 15,000 IOPS. B, the VM IO capping prevents the application from receiving the demanding IOPS. C, it is a disk that IOPS capping prevents the application from receiving the demanding IOPS.
I like this question. This one's a tough one.
Yeah. If you remember that chart, we have the VM and the associated disks, and the application is talking to the VM, and the VM needs to provide the necessary or required amount of IOPS to the application.
Yeah, this one's a true knowledge test. See if you're paying attention to the details.
Yeah. Okay, so I have some answers coming in. It's pretty diverse. I think we have people voted for each of them. The correct answer here is actually B. It is VM IO capped. So maybe I can quickly show you how, if we revisit the earlier slide here, the application requires like a 15,000 IOPS. However, the VM can only provide 12,800 IOPS. Although in the question that each of the disks can provide 5,000, adds up to the total of 15,000 IOPS, but the VM is a bottleneck that can only feedback response at the 12,800. So at that question, the VM was the bottleneck. Yeah, let me go to the slideshow. So VM only provides 12,800 IOPS. Okay, last question. Number 3. An administrator is creating an Azure VM by using premium SSD disks to run a marketing application. You have scheduled a planned marketing event for which you require a sustained increase in disk performance. Which of the performance scaling options should the administrator choose to meet the application requirements? So first is use disk bursting. Second is change the disk performance tiers. Third is use read-write caching on the disk. So please pay attention that you require kind of like a sustained increase in the disk performance. And it is a scheduled marketing event. Wow, great. I think we have the votes coming in, and they all voted on the correct answer, which is B, change the performance tiers. Changing the performance tier will provide a sustained and stable increase in the disk performance compared to bursting. And yeah, so everyone got the right answer for this one. Congrats.
Nice. Good job, guys.
Good job. So we have reached the end of today's presentation and the learning session. So in a quick recap, we have gone through the different disk types that are available in Azure, from HDDs, lower cost, to high performance ultra disks. And we have understand how disk performance works, IOPS, latency, and throughput. And Alex showed a wide range of different performance scaling options. We also have some new options like Performance Plus just came out as free option that you can fully use. So hopefully at the end, you will be able to have a better idea about what disks to choose, how to match the right disk with right VMs to avoid I/O capping, and all the different options, performance options. So for more resources, you can check the link here. And that will be all for today's session. Anything you want to add, Alec?
Not a whole lot. Thanks for coming out and listening to our presentation. Appreciate you guys tuning in. And thanks, Terrence, for co-hosting this event with me. I appreciate it, man.
Yeah, thanks, Alec. Thanks, everyone. Hope you enjoy the good rest of the day. And you can also watch the recordings of this session later. I think we shared the link there. And that'll be all. Thank you.
Thanks, guys.